Today we're diving into something really cool, a new kind of cybersecurity detective. It's an automated technology called WEIZZ, and its job is to act like a detective, finding these deep, hidden flaws in the software we use every single day. The goal? Find them before the bad guys do. So let's get into it.
Every single app on your phone, every program on your computer, it's all built on millions and millions of lines of code. And somewhere in all that complexity, there are almost always tiny mistakes, vulnerabilities, just waiting to be exploited. And finding them, well, that's one of the biggest challenges in cybersecurity. It's like looking for a needle in a digital haystack the size of a mountain.
So to really get our heads around this, let's use an analogy. I want you to picture a complex data file, like a high-res photo or a video file, as this incredibly intricate lock with thousands of tiny moving parts. The software that opens that file, well, that's the keymaker. But what if there's a hidden flaw in the lock's design? That flaw? That's a software bug. And finding it is the locksmith's problem.
Okay, so in the world of cybersecurity, the main way we try to find these flaws is a technique called fuzzing. It's basically an automated way to try and break the lock. A fuzzer will generate millions of slightly weird, malformed, or just totally random keys, that's the fuzz, and it just jams them into the lock one after another, hoping that one of them will hit a weak spot and cause the whole thing to break.
Now, until pretty recently, these automated locksmiths, these fuzzers, they really only had two main strategies for finding bugs. And as you're about to see, each one had a major drawback. So on one side, you've got the brute force method. Just think of a clumsy burglar trying millions of random keys. Sure, it's fast, but most of the keys don't even fit in the lock, right? They get rejected immediately, so you never really test the deep internal parts. On the complete other side, you have the blueprints method. This is where an expert human locksmith has to sit down and manually create a super detailed blueprint of the lock's inner workings. It's incredibly precise, but it is painfully slow, it's expensive, and sometimes it's flat out impossible if the lock's design is a secret.
And that's the problem, right? You're stuck. One method is too dumb, the other is too slow. This whole situation led researchers to ask a really brilliant question. What if we could build a detective that learns? One that doesn't need a pre-made blueprint, but could figure out the lock's design all on its own, just by listening to the clicks and whirs as it tries different keys.
And that is exactly what WEIZZ is. It's a new kind of gray box fuzzer. It's that smart detective we were just talking about, one that automatically learns the internal structure of the software it's testing. It basically creates its own blueprint, completely on the fly.
The creators of WEIZZ really put it perfectly, right here. Instead of needing to be told how a file is structured, WEIZZ figures it out by watching how the program itself reads the file. It sends in a little piece of data and then carefully observes which parts of the program light up in response to which bytes. It's literally learning the blueprint by watching the keymaker at work.
So how in the world does it actually pull this off? Well, the secret is this really clever process of finding clues and then tagging them to build out a complete map of the file. Let's break down how that actually works.
WEIZZ operates in two main stages. First up is the surgical stage. This is where it acts like a safecracker. It makes these tiny, microscopic changes to the input file. I'm talking flipping one single bit at a time, and it listens very carefully to see which part of the program's machinery clicks. It uses this info to learn and tag every single part of the file. Then it moves into the structure-aware stage. Now it uses that map it just created to make smart, intelligent changes to test the lock's deeper, more complex mechanism. Now, a core idea that makes all this possible is called input-to-state correspondence, or I2S. I know it sounds super complicated, but trust me, the idea is actually really simple. It's the observation that certain parts of a file, like a special code in the header, often get read directly into the program's memory without any changes. When WEIZZ spots this, it's like an aha moment. It immediately knows, okay, this sequence of bytes is a key that fits this specific part of the lock.
And this is where it all just comes together beautifully. Imagine WEIZZ is analyzing a standard PNG image file, like you see here. Just by poking and prodding, it automatically figures out, hey, those first 8 bytes, that's the file's unique signature. Then it learns the next 4 bytes to find the length of a data chunk, the next 4 to find the type of that chunk, and on and on. It's basically putting these digital sticky notes all over the file, creating a perfect structural map all by itself.
Okay, so this self-learning approach is incredibly clever, right? But the real question is, does it actually work? What happens when you let this AI detective loose on real-world software?
The results are pretty staggering. In its initial run, WEIZZ discovered 16 brand new, previously unknown vulnerabilities in software that people use every day.
These aren't just theoretical flaws. These are real bugs that could have been exploited.
And we are not talking about some obscure little programs here. WEIZZ found bugs in things like cups, that's the printing system used in macOS and Linux. It found a bunch of bugs in FFmpeg, which is a core piece of tech that powers countless video players, including VLC. I mean, these are mature, heavily tested applications where finding new bugs is supposed to be incredibly hard.
This table from the research paper really puts WEIZZ's achievement into perspective. It compares it to other top-of-the-line fuzzers. You can see that other tools, yeah, they can handle some of the hard problems, like magic numbers or data chunks, but they either can't handle everything or they need that manual blueprint we talked about. WEIZZ is the only one here that gets a check mark in every single box. It handles all these roadblocks, and it does it completely automatically.
And here is the visual proof. This chart shows a head-to-head test on the video program FFmpeg. The bars show code coverage, which is basically how much of the program's code each tool was able to explore and test in just 5 hours. And you can see it clear as day. WEIZZ, with its automatic learning, explored dramatically more of FFmpeg's complex code base than a competitor that needed manual setup. More coverage simply means a much higher chance of finding those deeply hidden bugs.
So all of this leads to a much bigger point. The invention of a self-learning detective like WEIZZ isn't just some small improvement. It fundamentally changes the game for how we defend our digital world.
What this really means, when you boil it all down, is that WEIZZ makes the most advanced, most intelligent kind of security testing as easy and as accessible as those simple brute force methods. No more manual blueprints, no more expensive, time-consuming setup. It really democratizes high-end security analysis, letting more developers find and fix flaws before they ever become a problem.
And that leaves us with a final, really important question to think about. Our software is only getting more complex. The digital locks are getting more and more intricate. As we move forward, you have to wonder, how many more critical vulnerabilities are out there, hiding in the code we rely on every single day, just waiting for a detective smart enough to finally uncover them?